Hey guys, so in this video we're going to talk about just examples of writing the equation of a line parallel or perpendicular to another line. So what I'm going to do in this set of examples is for every single example I want to satisfy the given conditions of a line going through the point 2, 3. And we want to put the answer in standard form with no fractions. So I have 4 different examples that I'm going to go through of those conditions so you can see them here. Okay, so we're going to start with having a line that's parallel to 5x minus 2y equals 10. Remember, we're going through that point 2, 3, and we want this in standard form. So the first thing that I've got to do here is I've got to write this in standard form, right, or in slope-intercept form, so I've got to solve for y. So to solve for y, first I'm going to bring the x to the other side, and then I'll divide everything by -2 to finish solving for y, so I get y equals 5 over 2x minus 5. And so now I can see that the slope that I have a slope of m equals 5 over 2, but I need something parallel. So the slope that I need then, well, you have to think about what does it mean to be a parallel line. So two lines are parallel when they have the same slope. So for my new equation, I need to use still the 5 over 2 slope, right? Okay, so now I've got a slope, this is the one that I need, and I have that point 2, 3. So now I can bust out the point slope form, right? This is the point slope form. So I can plug in all this information. So this becomes y minus 3 equals m. Oops, m. It's getting to be lunchtime, and I think my brain is not cooperating. Okay, so all right, so here's everything plugged in. And so now I want to get this into standard form. So let me clear some space. Okay, so first I've got to distribute that 5 halves. So this becomes 5 over 2x minus 5. Now I want to get the x and y on the same side and the numbers on the same side. So to do that, I'll have -5 over 2x plus y on one side, and then -5 plus 3 on the other side. Okay, so now if I were to simplify this just a little bit farther, so the only funny thing about this that I required is that we have no fractions. So if you want to get rid of the fractions, you just have to multiply every single part of the equation by the denominator. So I'm going to multiply this by 2, this by 2, and this by 2. And then that will allow me to rewrite the equation as -5x plus 2y equals -4. And so now that is the proper answer in standard form. Okay, so for the next example, so now I want to have a line that's perpendicular to 4x minus 2y equals 1. So once again, I've got to solve for y, so I'll go ahead and just bring the x over to the other side. I'll divide all sides by -2. And then I've got y equals, let's see, 2x minus 1/2. So in this case, the slope that I have in my current situation is m equals 2. But what slope do I need? Well, a perpendicular slope has to be the opposite reciprocal. So opposite signed reciprocal. So since this is a positive slope, I know that this needs to be negative. And then, so this is 2, so the reciprocal of 2. So remember, 2 can be written as 2 over 1, so then the reciprocal is 1 over 2. So the perpendicular slope is -1 over 2. So now I've got my slope, I've got my point, so I can plug this into my point slope form. So I can write this as y minus 3 equals -1/2 x, -1/2 times x minus 2. Okay, so let's go ahead and let's distribute. So this becomes y minus 3 equals -1/2 x plus 1. And so let me clear some space. And so now I'll bring the x over to the other side, the 3 to the other side. So I'm going to have 1/2 x plus y equals 1 plus 3. So I have 1/2 x plus y equals 4, but I can't have any fractions. So I'll multiply every part of this by 2 to get rid of the fractions, so that this becomes x plus 2y equals 8. And so now there's my equation in standard form with no fractions. So for our next example, now I want to have a line that's parallel to y equals 5. And y equals 5 is a horizontal line So I really just want a line that goes like in the same direction in the same form of y equals a thing. So if I needed to go through the point y, if I needed to go through the point 2, 3, remember I need the y coordinate to not change, so I just need to ensure that this y coordinate just stays the same. So the parallel line in this case will just be y equals 3. You can draw a little picture of this if you're not sure. So here's y equals 5, and then here's the point 2, 3. So the only way that this can be parallel is if this is the other line, right? And the equation of this line is going to be y equals 3. So if you're somebody that, would prefer just to have the visual, just consider drawing the graph. Okay, and so then for this last one, so remember I always say math isn't a spectator sport, so maybe you want to pause and think about this one for a second. So for this last one, so I want perpendicular to x equals 7. So this is a vertical line, so now I want to have a horizontal line. So a horizontal line will have the form y equals, so once again it's actually going to be the exact same equation, y equals 3. But if that is just like kind of blowing your mind a little bit and you're like, oh, I don't know if I could figure that out, 3, 4, 5, 6, 7. Okay, so here's x equals 7. So then just thinking about what does it mean to be a perpendicular line, it's got to run this way, right? And then you know that you need to have the point 2, 3. Your new line has to go through the point 2, 3. So this is the only line that can be perpendicular. And let's pretend that that went through 3. Let's pretend. Sorry. Let's pretend that went through 3. So the only line that this can be then again is y equals 3. So, if the horizontal and vertical lines, I think it's a really common thing. If they just kind of throw you off your game, then just consider just drawing yourself a little illustration. Okay, and so that is just a quick set of examples that I wanted to run through to go alongside with my lesson video. Hopefully that was helpful. I'll talk to you guys next time.